Hi everyone, welcome back to my channel again. So today we will be discussing something, the most important topic in computer networking, and it will be a game changer for you if you focus carefully. So why it is the most important topic in computer networking? So before we start or we go deep dive into IPv4 addressing, we need to understand why it is the most important thing and why it is the game changer for you. So in telephony system, what is the most important thing? The most important thing are the numbers. So if you know how the numbers are being routed, you know the telephony system. Uh, in computer networks, the most important thing are the IP addresses. So you might be thinking we don't use IP addresses, but definitely you do. In backend, what happens when you try to browse something, let's say google.com or cisco.com or juniper.com or apple.com, what happens in the backend? There is something called DNS server. That DNS server resolves the IP address on behalf of your request. So backend, it all about IP address. You got my point? So learning the IP address is the most important thing. If you know the IP addressing, if you know IPv4 address, how it works, if you know class of IP addresses, you know how to design the network efficiently. Okay, so we will not waste our time discussing about the importance now. Right now, we will go deep dive into it. Be with me. Thank you.
Shoot the camera, take the action, let's go for it. So let's start. First of all, we start with IPv4 addressing. So how IPv4 is being represented? We need to understand the structure of IPv4. In the structure of IPv4, this is my concept that there is 4 octet. It consists of 4 octet. So what does it mean 4 octet? Let's see an example. Let's see a classic example of IPv4 address, which is 192.168.1.1. So this is an example of IPv4 address. Agree? So here, this what we have written so far. This is the first octet. Sorry, this is the first. This is the second. This is the third, and this is the fourth octet. So what does it mean by octet? Okay. As a whole, IPv4, we are writing down this whole thing in which format? That is called decimal format. Okay. But in backend, how computers they calculate, or how computers they comprehend, or how computers they work in backend. So it doesn't work in binary. It doesn't work in decimal format. It works in binary format. Okay. So what is decimal? Decimal is something where we represent the whole thing or the number with 0 to 9. So anything 0 to 9, this is decimal format, which we as a human, we are used to. What is binary format? Binary means anything 0 and 1, or 1 or 0, 0 or 1. Okay. So computer doesn't want to understand anything in decimal. So whatever you write as a decimal as a human, in backend it is always converted to binary format. Okay. Before, in fact, this is a 32 bit. It consists of 32 bit, which means 32 binary digits. Okay. So 32 binary digits. They make it simpler. What we have done first octet, which consists of 8 bits. Second octet, again 8 bits. Third octet, again 8 bits. Fourth, it's again 8 bits. Okay, so what we can see here, 4 multiplied by 8 is equal to 32 bits. Clear? So let's try to understand more deeply. Let's try to convert the decimal. So our example, we have considered as 192, 168, 1.1. So 192 is what exactly? It is in which format? It is in decimal. Let's try to convert this one into binary. Once you convert this one into binary, life will be easy. It will be very easy to understand. So as we discussed a few minutes back, in IPv4, the first octet, which is 192, is 8 bits. So how we are representing or how we are converting them in bits? Let's try to understand. In binary digits, there are only two place values. Oh, sorry, I mean in binary, there are only two numbers, which is 1 and 0. But there are some place values are there. If you are considering 8 bits, okay, the first bit, this is the first bit, this is the second, this is the third, this is the fourth, this is the fifth, sixth, and seventh. Okay, so one, two, first, second, third, fourth, fifth, sixth, seven, eight. Okay, 8 bit. So 2 to the power 0 is equal to 1. The next one is 2 to the power 1 is equal to 2. Okay, so in this way, 1, 2, this is 2 cube is equal to 8. Okay, so if we consider in this way, so the first bit is, if you place 1 in the first place value of the bit, so it is 1, then 2, then 4, then 8, then 16, then 32, then 64, then the next one is 128. So we should not be bothered about 256, 512 and beyond. So actually we should be only concerned from 1 to 128, because how we are representing it is all 8 bits and octet. Octet means 8 bits. Okay. So let's try to convert 192, which is in decimal, and let's try to convert this one into binary format. So if you are considering binary format, definitely what we have to select 128 first. So this will be 0. Okay. So remaining is 64. So you have to consider place value over here, it's 1. So if you consider the rest, this is how you write or you convert 192 decimal into binary. As simple as it is.
So let's try to understand how we can represent 168, or how we can convert 168 from decimal to binary. So if you have to write down 168, in that case we have to first select 128, as you have seen. Then the remaining will be 40. So 40 means we have to select 32 from binary digit, place value of 32, and then we have to select place value of 8. So this is how we can represent 168, as you can see over here in the example. So that's the example, that's the method how we can convert 168 from decimal to binary. Well, now let's see the next example.
So if we are considering what is the maximum value of one of the octet, that is 255. So, well, let's do the other way around. Instead of converting from 255 to binary, we will convert from binary to decimal. So in that case, we will write down all of them if it is 1. Okay. So in that case, what will be the binary to decimal? In that case, it will be 255. Well, now let's see the next example. In the next example, we will try to convert the decimal one to binary. If you are converting decimal one to binary, by default it's 1. But if we are trying to represent them in a format of octet, keep in mind that this is in octet format. So in octet format, we have to write 8 bits. So if we have to write 8 bits, in that case, first 4 are 0, the next 3 are 0, and the last one will be 1. So this is how we are going to convert from decimal 1 to binary. So now let's write down the whole IP address into binary format. So which will be first 2 of them will be 1, then zeros. So first octet is done. So second octet is 168 again. Okay, so next third octet is 0, all zeros, and last is 1. So third octet is completed. Fourth octet will be the same, which will be 7 zeros, 7 leading zeros, and then 1. So this is how computer converts the whole into binary. So even if you administratively assign IP address or via DHCP, you might see the IP address as 192.168.1.1, which is in decimal, but in the binary, this is how it is. So right now you guys have understood how IP address is structured. So we'll see other few things like subnet mask, gateway, default gateway, I mean to say, and then class of IP addresses. Class of IP addresses based on number of network and number of host. So before we go through the classes, let's try to understand from the telephony system point of view. So before we go deep into the classes, why there are classes, let's try to recap that example of telephony system. In the telephony system or in the PSTN network, if you look into the number carefully, there are actually two sections are there. One of them is network portion and one of them is host portion. So let's see a classic example of a telephone number. This is my friend's telephone number. Actually, I'm writing it down. Well, I'm not going to show the whole thing. I have masked the last 4 digits. So you will see the first one belongs to country code, then the area. So the area is New York, and the next one is operator, and the next 4 digit belongs to the customer. So let me give you an high level overview of how the telephony system works. Again, our scope over here, it is not PSTN network or telephone exchange system, but this is just to give you an example and to understand a logic how it works. So once you understand this logic, it will be very easy for you to understand and comprehend the logic of computer network also. So if you see over here, country, area, and operator consist of network, correct? So once you dial this particular number from San Diego, California, why I'm giving you an example, because both of my very close friends are living, one of them is in New York and one of them is San Diego, California. So If one of them dial from San Diego, California to the number of to New York number, what's going to happen that the exchange is going to look into the network section or the area and the operator. So the exchange, it's having its own database, so it will look into the database and it will forward the call to the exchange in New York, and eventually from there it will be ringing to the customer telephone or customer mobile number. So this is in general or in short how PSTN network works. In computer network also, specifically for the IP address, in the IP address section there are two portions. One of them is network, another portion is host. So let's try to understand what is that network portion and how it works further. So let's think about a moment that how or what is internet actually. So internet is network of networks. So let's draw a simple diagram. Uh, let's consider this is the internet, where we have network 1, we have network 3, network 4 and network 5, and all of these network are interconnected with each other. So this is a very high level example of internet, how it works. So let's consider that you are working for a multinational company. Let's say you are working for Google, and you are the network administrator for different sites or their different networks. So let's name those networks. One of them is, let's say, DC. Well, next one is, let's say, New York, then Dubai, and we can consider the next one Australia, for example, Australia, Sydney. And the next one we can consider India, Bangalore. Similar to what we have discussed, that in telephony system it's all about the telephone number and how the telephones are being routed. Over here in the computer networks, the network are connected with each other through a router. So these routers have a database. Let's say you want to reach from DC network to India network. In that case, it will look into its routing table. So let's have a quick understanding what is a router. What is the functionality of router? Router, there are two functionality. One of them is packet switching, another one is packet filter. Our scope over here is only to understand more into packet switching, but also it will be very high level. Packet filter is like access control list, or you can say restricting the traffic. So let's say a machine from DC, let's say a machine or a user called David, he wants to reach from DC network to India network. In that case, his packet or his traffic will go to router 1, which is his default gateway. So that default gateway or that router will see, or it will dissect the destination IP address, and it will try to identify what is the destination network out of it. So it will look into the destination network and it will look into its routing table, something called. So once it consults its routing table, it will take a decision that which is the best path or what is the path to reach India. So in network 1, where router 1 is, let's say router 1 is responsible, so it will look into two interfaces. One of them is A and B, and let's say based on its routing table, it will take a decision that I will switch the traffic from interface A, and it will forward the traffic to India. So now from this particular diagram, okay, each network is represented or it is actually identified by its network address. So whenever David tries to reach any of the network, the router will be looking into his routing table and it will be forwarding the traffic. So let's try to understand over here. Based on this principle, let's say you have been asked that you are responsible for creating or designing a computer network where 100 sites will be there, where or 100 networks will be there, and under each 100 sites there will be 50,000 users. So how you are going to design the network? So let's come to the class of IP addresses. So based on this information or based on this requirement, how many number of networks and how many number of users you will have, we have different class of networks. So sorry, different class of IP addresses. One of them is class A, class B, class C, class Delta, and class E. So class A, this is how, I mean, in shortcut I'm showing. First 8 bit is network and the rest of them is host. For class B, it is like this. Let me explain you. Let me just write it down. Class D and class E we will discuss after a while. So over here in class A, 8 bit belongs to the network and rest of the bit belongs to the host. On class B, the 16 bit belongs to the network and rest of the 16 bit belongs to the host. For class C, first 3 octet belongs to the network and the last octet belongs to the host. Okay, so what about class D and class E? So class D, it is used for multicast purpose, and class E, it is used for research purpose. Okay, what is multicast? Okay, before we go deep into the multicast, generally there are 3 types of communication in computer network. One of them is unicast, the next one is broadcast, and the other one is multicast. So unicast is what? Let's say I am inside a classroom and I am providing my lecture in English, and this English is known to everyone. So in that case, this is an example of broadcast message. Now let's say I went near to Mr. David and I'm asking him a particular question. Hey Mr. David, do you understand IPv4? Mr. David is responding me, yes, I do understand. So this is a unicast communication, example of unicast one-to-one communication. What about multicast? Let's say a group of people in the classroom, let's say out of 100, only 20 people, they knows Latin. And I want to convey my message to those specific group of people. In that case, it will be an example of multicast. Well, here our scope is not to discuss multicast. It's just a high level example of how multicast works. And in real life, in in computer networks, the application of multicast is used in IPTV, CCTV camera, and many other applications. So, which is not part of our current discussion today. So let's go deep into each of the classes. So let's start with class A network. In class A network, we have first octet is network and rest of them is host. So host, we have 24 bits. It's 888. So 38 8 multiplied by 3, which is 24. So if we consider 2 to the power 24, let's do a math, how much it will come. So it is 16 million IP addresses. The 16 million IP addresses can be accommodated in class A. Now let's do a math for number of networks. It should be like 2 to the power if the first octet is network. So that means in that case 2 to the power 8, which is equivalent to 255. Yeah, 2 to the power 8 is equal to 255 network addresses we can accommodate. So that means if you use a class A IP address, in that case you have unique 255 network address, and under each network you can have 16 million IP addresses or host addresses. So let's see the class B network. Under class B, the first 2 octets are network and rest of them are host. So that means 2 to the power 16, which is equal to 2 to the power 16, which is equal to 65,536. On the other hand, for the host, also we have the same number of host addresses, which is 65,536 hosts. So under each 65,000 network, we have 65,000 hosts. So let's move to class C addresses. So class C addresses, if we recall, the first 3 are for network and the rest octet is for host. So the first means 2 to the power 24 is for network and 2 to the power 8 is for the host. So host we get 255 IP addresses, that's correct. And for the network, let's do a copy paste, 16 million, yes. So 16 million 16 million network addresses are possible using class C network addresses. So that means under each 16 million network address or network ID, we have 255 hosts. So I will just give you, we will not go into it now, the network address and broadcast address. Practically, we can support 253 actually hosts. Theoretically, this is the number of hosts because we have to minus network address and minus broadcast address. So 253 hosts. We will discuss in our next part what is exactly how the network address is calculated and how the broadcast address is calculated and what is the use of them. Okay, so let's see the examples of class A, class B, and class C IP addresses and how we can identify that this IP address belongs to class A, class B, class C, or class D or class E. So it's all on the first octet. For class A, in the first octet, if it is 1 to 126, that is class A IP address. So for class B, it is 1282191. Class C, it is 192 to 223. So this is the range, and let's see the example of class A. So 10.1.1 you can see the first octet is within the range of 1 to 136. Class B, it is 172.16.1.1. So 172 falls in the range of 128 to 191. So our class C, it is 192.168.1.1. So it falls under this range. If it is falling under this range, 192 to 223, so it belongs to class C IP address. So class D, it is 224.2239, and class E is 240.2255. So the next thing is, most important, is subnet mask. So what is the purpose of subnet mask? Before that, today at your home, if you have a Windows laptop, try this one. Go to CMD. Oh, I'm sorry. So go to CMD and type this one, ipconfig. Once you type ipconfig, you should see these three information: IP address, subnet mask, and default gateway. So all these three information, which is IP address, subnet mask, and default gateway, all of them, it might be obtained by the DHCP, or by manually. So manually means someone as a network administrator, he or she might have assigned the IP address. DHCP means automatically it might have received those IP addresses. So now the most important thing is, what is the function of subnet mask? You will see, once you assign IP address and once you assign the subnet mask, they do something in the backend, which is they do AND operation. Once they do AND operation, the machine tries to find itself that, okay, if I have been given IP address and if I have been given my subnet mask, what will be my network address? So let's convert them into binary and let's see how it works. So 192, let's convert this one. So this is the first octet, 192.168 and 1. It's quite easy to write down. Okay, so we are done. Let's write down the binary for subnet mask. So it should be all 1 for the first 3 octet and then 0 for the last octet. Okay, so let's do an AND operation. So this is the result of AND operation. So in the AND operation, we can see the decimal. Actually, if we convert this to a decimal format, it will be 192.168.1.0, which means it's purely the network part without the host portion. So that's called the network address. And we will define this one by something called CIDR notification, classless interdomain routing, CIDR notification. So here 24 means 24 bits belongs to network. That's the meaning of it exactly. Okay, so we will see the example of others also. This is class C. So in class B, it is first 2 octet. That means it should be /16 as a CIDR format. So /16 means 16 bits purely into the network. So let's see the next example of class A. In class A, first octet is network, rest of them belongs to host. So that's why we are defining this one as a /8 CIDR format. So whatever you have learned now for class A, number of network bits, class B, number of network bits, class C, number of network bits, these are like typical. That means you can do customization, which will which is another concept called subnetting. And there are further enhancement we can do, that is called VLSM, which is variable length subnet mask. So for the time being, guys, thank you for being with me for this long, and I hope this session has been informative to you. So see you guys in the next class, where we will discuss on subnetting, VLSM, and some real life design examples. And the last thing, guys, don't forget to like, subscribe, and share our channel. Thank you so much.